Let's learn about solving absolute value equations and inequalities. The absolute value of A went to donate some blood. That's impossible. I can't have a negative blood type. On our agenda, we're going to solve absolute value equations and inequalities. We're going to have to consider all of the options, and we'll do a graphic check. Let's get ready by grabbing your pencil, notes, and calculators. Pause and do the problems along the way. We're going to do 5 problems together. So here we have an absolute value equation. We want to get the absolute value bars all by itself. So I'm going to add 3 to both sides. I have the absolute value of 2x plus 7 equals 11. Once you get the absolute value bars by itself, that's when you want to set it equal to the positive and negative value of that. If we think about our number line and we are at 0, if I go to 11, that is 11 units away. It's a distance of 11. If I also go to negative 11, that is also 11 units away. So we need to consider going to 11 and negative 11 and solve both of those. So I can drop the bars, set it equal to 11, drop the bars and set it equal to negative 11 and solve each of those separately. So x equals 2 and x equals negative 9. You're usually going to have 2 answers for your absolute value equations. To recap the steps, you want to isolate the absolute value by getting it by itself by undoing operations. You have to add or subtract, you have to divide. Then you want to set it equal to the positive and negative values of that number. Go ahead and solve each equation, and you must check your solutions. You want to see if you have any extraneous solutions that you will have to reject if they don't work. I want you to pause and try this absolute value equation. Now I'm going to do it. So I'm going to add 5. And now I have 1/2 times my group, so I want to undo the 1/2 by multiplying everything by 2. Remember to go to the other side of the equal sign, so I'm going to get 26. And here again, now I'm equal to 26. So I have my bars by itself, so I want to drop the bars and set it equal to 26 and set it equal to negative 26 and solve. So x equals negative 10 and x equals 22/3. Before we get started, when we move to absolute value inequalities, what is the rule when you're solving inequalities? Hopefully you remember that when you're solving inequalities, you have to remember to flip the sign when you multiply or divide by a negative number. Multiply or divide by a negative number, flip your sign. So I'm going to undo this. I'm going to subtract the 14 and get negative 30. I'm going to divide everything. That's supposed to be a negative 2. Divide everything by a negative 2. And because I am dividing by a negative, I want to flip my inequality sign. And now I have the absolute value is less than or equal to 15. So just like we did with our equal sign, we would do 15 and negative 15. I'm going to do the same thing, but when I do it with negative 15, I have to flip the sign again. So we have 2x plus 3 is less than or equal to 15, and 2x plus 3, flip it, greater than or equal to negative 15. Go ahead and solve each of those, and I get x to be less than or equal to 6, and x to be greater than or equal to negative 9. Those are my 2 answers. They are inequalities. So when we think about those with an inequality, remember it represents a range. So if I come to 6, I'm going to put a closed circle, and negative 9, oops, I can't quite get it with my bars in the way. That's supposed to be a negative 9 up there. And then we would shade everything to negative 9 all the way there. And then I want you to write that using interval notation. So because we have the equal sign under both because we have both as closed circles. These are going to be hard bracket, -9 to 6, to include my answer. Go ahead and pause it and try it here. I'd like you to solve it, graph it, and state it with interval notation. So you should get it to the absolute value of 4x plus 7 is greater than, because you should have flipped along the way, 3, and then you get x to be greater than -1 and x to be less than -2.5. These are both going to be open circles, and greater than -1, less than -2. So I have two pieces to my answer and interval notation. It's going to be soft bracket -infinity to -2.5. And then we use U for union, and then -1 to positive infinity. All right, let's take a look at this. This was our example 1 and what's going to be our example 5. And what do you notice? Hopefully you notice the one that we've already done had one absolute value bar, but this one has 2. So this makes it a little more interesting. When you have 2 absolute value bars, we need to consider all the ways that this might be positive and negative. So left side, right side. I could keep them both positive, positive, positive. I could keep the right side positive and the left side negative. I could make the left side negative, right side positive, or I could make them both negative. So we're going to have to go through this, and again, you're going to take your time, watch your negative signs, and when we're doing this, I'm thinking of my absolute values as parentheses, so when I change them to negative, I'm distributing a negative through. I'm not necessarily just changing the sign within the absolute value. So let's take a look at our examples. So I'm going to keep the first one positive, so I'm not really changing anything. And I end up, my x's will cancel, so I have -2 equals 4, which is not a true statement, so that does not lead me to a solution. I'm going to keep the left side positive, and not the whole right side, just the absolute value. So that just stays a +1. And I'm going to go minus parentheses x plus 3. I have to be careful to distribute that over there. So I'm going to get a -x and a -2. So I add the x over and I get 2x, add that 2 over, I get 0, x equals 0. Let me see if that works. So when I plug in 0, I'm going to get 0 minus 2 is -2. So the left side becomes 2 and the right side becomes 4, which does not give me a solution either. So now I'm going to make the left side negative. Let's get a better color. And I'm going to keep the right side positive, distribute that. And I'm going to add my x over, subtract the 4, and x equals -1. When we try that, I get 3 on the left, and I also get 3 on the right. So that is a solution. That one does work. And let's try this last one. I'm going to make them both negative. Distribute. And oops, that should be a negative there. So my x's are going to cancel and I have 2 equals -2, which is not correct either. So I am only going to have one answer here, and that x equals -1. Let's take a look at why this works, and we're going to do a graphic check. So we're going to graph each side. This is y equals this equation, and y equals that equation. We'll graph them each separately as a system, and then see where they intersect. So if I think about the shift, my blue graph is shifted to the right 2, although it's my red graph here. And then my other one is shifted left 3 up 1, so I am over at that point. They both have a slope of 1, so I have my V shape, and I can see that their point of intersection is in fact negative 1, 3, which means that x is negative 1, so it works. And we can also see why nothing else worked, because they're only going to intersect at that one spot. Good job.